Hi everyone, this is your math guru. In this video, I'm going to show you how to apply some trigonometric rules in order to solve the following. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the following diagram, angle CBD is equal to angle AEC, which is equal to 90 degrees. Angle BCD is equal to angle CAE, which is equal to alpha. Angle ACB is equal to beta, and the line BD is equal to x. 1. Write down the size of angle BAC in terms of alpha. 2. Determine the length of BC in terms of alpha and x. And 3. Hence, prove that line AC is equal to x cos, open bracket, beta minus alpha, close bracket, all divided by sine alpha. 1. So write down the size of angle BAC in terms of alpha. We have angle BAC equals to angle ACE. And the reason being, they are alternate angles because the line AB is parallel to the line EC or CE. So if you look at the two parallel lines AB and EC, we have the alternate angle. I'm going to draw at Z such that the angle at C as shown and the angle at A as shown are the same. Therefore, to find AEC or ACE, we are looking for this angle as highlighted. ACE plus angle E plus angle CAE is equal to 180 degrees, the sum of angle in the triangle ACE. All the angles in the triangle, when added together, will give you 180. Therefore, ACE plus angle at E, that's 90 degrees, plus CAE alpha equals 180 degrees. So therefore, to find the angle ACE, I'm going to move all the other terms to the other side. So I have 180 degrees minus 90 degrees minus alpha. Therefore, angle as shown in the first statement, that the angle BAC AC is also equal to ACE, alternate angle, which is equal to, we have 180 minus 90, 90 minus alpha. So we've been able to write the size of angle BAC in terms of alpha. Let's go to the second part of the question. The second part of the question says, determine the length of BC in terms of alpha and x. To find the length BC, as highlighted, I'm going to use the triangle CDB or BDC. So if I draw that out here, it's a right angle triangle, and so I'm going to apply the trigonometric ratio. I have x, I have this as D, and this is point or angle C. Angle C, I have that as alpha. Note that angle BAC, that's part of question 1. So therefore, to find the line BC in reference to the angle C, the side DB facing the reference angle is my opposite. I'm going to write my opposite here. The longest side, CD, that's my hypotenuse. And the third side is your adjacent. So if you look at our trig ratio, we have a SOHCAHTOA. The trigonometric ratio to use, because I'm looking for my adjacent, I already have my opposite. Then I'm going to use my tan. Tan states that tan theta is opposite over adjacent. So stating that, I have tan alpha, in this case, equals opposite over adjacent. Tan alpha equals my opposite, that's x, over adjacent, the line BC. Tan alpha on this side is over 1. So if I cross multiply, what I have will be BC multiplying tan alpha equals to x. Dividing both sides by tan alpha, I have my BC equals x over tan alpha. Let's look at the last part of the question. The third part of the question states that we should prove that the line AC equals x cos in bracket beta minus alpha all divided by sine alpha. The triangle I'm going to use for that is my triangle ABC as shown. If I draw that out here, I have question 3. The triangle ABC is angle BAC is 90 minus alpha as shown in the first part of the question. So I'm going to fill that up as 90 minus alpha. Then I have the line BC to be x over tan alpha. I also have my angle at C to be beta. So therefore, to start with, I'm going to solve for angle at B. The sum of angles in a triangle add up to 180. So I have angles A plus B plus C equals 180 degrees. That's sum of angles in a triangle ABC. Therefore, putting in the value, I have A to be 90 minus alpha plus beta, or for plus B, that's a correction. I'm looking for angle B plus C, that's beta, equals 180 degrees, making angle B my subject word formula. I have therefore angle B equals 180. I'm going to move every other term to the other side, minus 90 degree plus alpha minus beta. That will be 90 degrees plus alpha minus beta. And if I rewrite that, that will be B, or angle at B, equals 90 minus beta minus alpha. The signs will change, 90 degrees. So using our sine rule states that sine A, or I put the length at the top, I have A over sine A equals B over sine B, which is equal to C over sine C. In this case, I have A, that's the line AC. I'm going to start with the line I'm looking for, which is AC. So I have line AC over sine of the angle facing AC. In this case, I have sine 90 degrees minus beta minus alpha, close bracket. I'm going to extend my fraction bar, equals, the other side I know is the line BC, and in this case, BC is, I'm going to write that as BC over sine of the angle facing BC. If you look at BC, the angle facing BC will be 90 minus alpha. Simplifying this, what I'm going to have is, I know BC to be x over tan alpha. Also, note that sine 90 degrees minus alpha is the same as sine of, no, that's going to be cos, that'll be cos of alpha. So simplifying what I have AC over sine, that's going to change to cos, so that'll be cos of beta minus alpha, close bracket, equals, I have my BC. BC in this case is my x divided by tan alpha, all divided by sine 90 minus alpha, that's the same as cos alpha. Simplifying, this will be AC over cos beta minus alpha, close bracket, equals, I'm going to work that on the side. I have x over tan alpha divided by cos alpha. This is going to be x over tan alpha times 1 over cos alpha. Remember, my tan alpha from my identities is the same as I have tan theta from identity rules equals sine theta over cos theta. So changing that here, I have x over sine alpha over cos alpha times 1 over cos alpha. If I simplify, that will be x cos alpha over sine alpha times 1 over cos alpha. Cos alpha cancels each other, so what I have finally is going to be x over sine alpha. So what I have on my right hand side becomes x over sine alpha. From here I can easily cross multiply and what I have will be AC multiplying sine alpha equals x times cos beta minus alpha, dividing both sides by sine alpha. This cancels, therefore my AC is equal to x cos beta minus alpha all divided by sine alpha, which is the same as what I have here. Thanks for watching. Bye.